The Constitution of India. Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. We are getting into the last organic part for today, which is amines. We have been hearing this word amines, like we know when an NH2 group is added, it is called as amines. But exactly how does it function, or how it is being substituted, or what are the properties of amines, we will learn now. Amines constitute an important class of organic compounds derived by replacing one or more hydrogen atoms by ammonia molecule. So what happens, this ammonia molecule, one of the hydrogen atoms, the number of hydrogen atom getting replaced will be giving an amine group. That is, in NH2, hydrogen getting replaced by alkyl group or aryl group, we will be getting our amines. So they have been used in polymers and also in drugs, and also they have been used in dentistry and also in medicinal purposes. Now if you see how amines are considered, amines can be considered as derivatives of ammonia, which is obtained by the replacement of 1, 2 or 3 of the hydrogens. All the 3 hydrogens can also be replaced, we will be getting amines. So if one of the hydrogen is replaced in ammonia, you get primary, these are all primary. 2 hydrogens are replaced, you get secondary. If all the 3 hydrogens are replaced, you get the tertiary amine. Nitrogen atom of amines is trivalent because we know the valency is 3 and it carries an unshared electron pairs. So we know it forms a pyramidal structure. And if you want to see the structure of amine, this is the tertiary amine, trimethylamine. So this nitrogen having an unshared electron pair in its orbital. Now amines are classified as primary, secondary and tertiary depending on the replacement of the hydrogen atoms. And to be precise, if you see the structure here, NH3 is ammonia. When one hydrogen is replaced, you call it as primary amine. When 2 hydrogens are replaced, secondary, and when all the 3 are replaced, it becomes a tertiary amine. And now nomenclature, you can just refer the textbook tabular column which is given there. Now let us see how we can prepare amines effectively. First is reduction of nitro compounds. Nitro compounds can be reduced to amine using hydrogen and palladium. That is, if you want to add hydrogen, because in amines you know nitrogen is being accompanied by hydrogen atoms. So if you want to replace, you will be doing with addition of hydrogen using palladium as catalyst. So NO2, nitrobenzene, on treatment with hydrogen and palladium you get a amine, this is aniline. Similarly, when it is treated with tin and HCl or iron and HCl, you get a primary amine. Now when you do the reduction with iron, it is always preferred because it gets hydrolyzed to release hydrochloric acid during the reaction. So how do they ask you in the exam is, what happens when nitrobenzene is reduced, or how can you prepare aniline using our nitrobenzene? Next is ammonolysis. Ammonolysis, it's very simple, where the carbon halogen bond, you know we have studied about nucleophilic substitution reaction. There exactly you know what is happening. The halogen atom is getting attached, or you know a new nucleophile comes and replaces the older one. So this is my nucleophile ammonia. When it is treated with Rx, that is an alkyl halide, this nucleophile comes and attacks my carbon center. So you get RNH3 plus X minus. Then what happens? This becomes a salt which gives rise to continuous salt, that is it gives the primary, on Rx gives secondary, again on Rx gives tertiary, because number of R becomes more and number of hydrogen becomes less, and then you get the quaternary salt. Though we use this reaction, there is one disadvantage, because if we need only primary, this reaction does not stop. It continues to form the secondary, tertiary and quaternium salt, where the reaction cannot be stopped at one particular stage. That is the only disadvantage of this reaction. Next is reduction of nitriles. We know what are nitriles? We also call it as cyanide RCN group, which when again treated with hydrogen and nickel as a catalyst undergoes hydrogenation, catalytic hydrogenation, to produce the primary amines. You can also use sodium amalgam and ethanol as a solvent, again you get the same primary amine. Next one is, once we use nitrile, the next one must be amide. So amide, strong reducing agent, you use lithium aluminium hydride, which on further hydrolysis will be giving my primary amine. So these are again the two processes. The next one is quite important. It's a name reaction which we call it as Gabriel synthesis reaction or Gabriel Thalamide synthesis. Observe the reaction very carefully, because it's a repeated question in the board, where this is Thalamide, which we studied in benzene carboxylic acid reaction. Thalamide, on treatment with potassium hydroxide, this hydrogen bonds break and combines with OH to form water. Potassium comes and attack nitrogen, and you get N minus K plus, which on treatment with RX, that is an alkyl halide, K combines with a halogen, comes out as potassium chloride or potassium bromide, R comes and attacks with my nitrogen. So you get alkyl thalamide. Now this alkyl thalamide, on treatment with sodium hydroxide or any base aqueous solution, you get this bond breaking. So you get COONA, again COONA. So you get the salt, which again gives a primary amine, because what breaks here, R combines with N and hydrogen comes and joins here. So you get your primary amine. So this is called as Gabriel Thalamide synthesis reaction. Okay, where thalamide is getting reduced to my primary amine. Next one is Hoffmann bromamide reaction. Again, it's a very important name reaction, where amide on treatment with bromine in presence of sodium hydroxide. These two combinations are important. Halogen in presence of an alkaline or a base, you get your primary amine, sodium carbonate, sodium bromide and water. So there is a definite reaction where it's been asked so many times, maybe in fill in the blanks also. So these are the 6 important methods of preparation of amines. Properties, if you see, they are lower aliphatic amines are soluble, and as the number of groups increases, the boiling point differs actually. If you see primary, secondary and tertiary, both primary and secondary have got a hydrogen bonding, but if you see tertiary, they do not have this intramolecular hydrogen bond formation. So that's why you say primary boiling point is more than secondary, which is again greater than our tertiary. There is a comparison given here. Now we will move to chemical reaction. Now difference in electronegativity between this carbon and nitrogen or nitrogen and hydrogen atoms because of an unshared electron pairs in nitrogen makes it more reactive, makes amine actually more reactive. The number of hydrogen atoms attached to the nitrogen also decides the course of the reaction, whether the reaction can take place to a greater extent or not. We studied COOH when we were studying, we said it's more acidic in nature. Similarly, when we talk about amines, they have a basic character. Amines being basic in nature, they react with acid to form the corresponding salt. Any acid combines with the base to form its salt. So that is what is given here. Now let us compare the basicity. Just like we did for COOH group, you need not by heart all this. We know amine salts are soluble in water, but they are insoluble organic solvent. They are highly basic in nature because of this pKa value or pKb value, equilibrium constant value with base, dissociation constant. The next important is the structure basicity relationship of amines. When alkyne amines is compared with ammonia, which was more basic in nature. See, when you say CH3NH2 or when you say NH3, here one of the hydrogen is replaced by a methyl group, which is an electron releasing group being alkaline. It pushes the electron towards the nitrogen and makes the unshared electron pair more available for sharing with the proton of the acid. So, the substituted ammonium ion which is formed by this amine gets stabilized due to dispersal of the positive charge of plus I effect. What is plus I effect? Electron releasing effect. These electron releasing group, when it releases electrons on nitrogen, there will be more number of electrons which are available for accepting the proton. That is why they can combine with an acid to form its corresponding salt. So what happens here? Alkyl amines will be stronger bases than ammonia. This is the case when you have gaseous state. But what happens when it is in aqueous form? In aqueous form, not only the electron releasing group, but the solvation of water molecules are also important. Where you can see the structure here. In primary, there are 3 hydrogen atom, 3 OH2 groups. So here there are 2 hydrogen, 2 OH2 groups. In tertiary, only 1 hydrogen. So solvation will be least here in tertiary and will be more in the primary. So when I said in electron releasing group, tertiary amines are actually more basic than secondary than primary. But here when you take the solvation in aqueous state, primary, it is the reverse state where primary becomes more stable than secondary than tertiary. So that is the difference in the nature of amines. That is the total conclusion is that the inductive effect and the solvation effect and steric hindrance of the alkyl group plays a very important role in deciding the basic strength of alkyl amines. But when you take aryl amines, what happens here? When we are talking about benzene ring, definitely we should talk about resonance. When you take aniline, which is an aromatic amine, there is a definite resonance structure possible, so which makes it resonance stabilized and therefore that becomes more stable. But when you take ammonia here attached to salt, ammonium salt of benzene, only one resonance structure is possible. So this shows that which is more stable here. We know that greater the number of resonating structure, greater will be the stability. So you can always say aniline is more stable than anilinium ion. Hence the proton acceptability or the basic nature of aniline and other aromatic amines will be less than that of ammonia. Compared to ammonia, it will be very less. So we said alkyl amines are stronger bases than ammonia, but aryl amines are less basic than ammonia. Now we will get into the reactions in which we have acylation, alkylation. What happens when an alkyl group gets added? You get primary, secondary, tertiary amine, and here in acylation if you see here, ethanamine, when it is treated with an acid chloride, what happens here? C2H5, this lone pair of electrons will attack my carbon, so this hydrogen goes up, COCl3, CH3 gets added and this becomes a continuous with the removal of HCl, hydrogen and chlorine comes out. So the remaining will be my amide, ethylene ethanamide. So another reaction is also given here with acid chloride. Okay. Next is a name reaction which is very important, test for the presence of primary amine. The next few reactions are all the test for differentiating primary, secondary and tertiary amine, which is called as a Carbelamine test. Primary amines, when it is treated with chloroform in the presence of potassium hydroxide on heating, will give an isocyanide. This reaction is also called as isocyanide test, where the secondary and tertiary amines will not show this reaction. Only the primary amines can react and it will be giving my corresponding isocyanide, which is called as a carbelamine reaction, where you get a foul smell when you do this reaction. The product will be having a foul smell. The next one is reaction with nitrous acid. There are three important classes of amines with different reactions, where you see the primary amines when treated with nitrous acid with sodium nitrate and HCl, you get a diazonium salt. That is the primary salt with N2 plus and Cl minus, which on hydrolysis will give an alcohol. Now if you see here, quantitative evolution of nitrogen is used as the estimation of amino acids and proteins. Aromatic amines will give a benzene diazonium chloride, but the secondary and tertiary amines do not react in the same manner how the primary aliphatic amine and the primary aromatic amine react. So here it is also a reaction which helps us to distinguish between the primary and the secondary amines or the tertiary amines. Next one is reaction with aryl sulfonyl chloride. What is aryl sulfonyl chloride? Where benzene sulfonyl chloride, you have a benzene ring, SO2Cl. We call this as thionyl chloride, SO2Cl. But this, when is attached to the benzene ring, you call it as benzene sulfonyl chloride, which is also called as Hinsberg reagent. It's a 1 mark question again. So this, when treated with a primary amine, what happens here? You get a soluble salt of alkali with HCl. So here you see Cl comes out, one of the hydrogen comes out, this directly gets attached. So this is a removal of HCl taking place. So this is a Hinsberg reagent. Tertiary amines do not undergo, primary undergo very fast, secondary little bit slowly, tertiary do not undergo this reaction. So this is again a reaction to differentiate the three classes of amines. Next we have electrophilic substitution, where we know electrophile comes and attack my benzene ring. So aniline on bromination with bromine water, you get tribromoaniline, where again remember children, electron releasing group, so not meta position, our ortho and para position gets occupied. So you get 2,4,6 tribromoaniline with HBr. Okay, so this, the main problem which is encountered during this electrophilic reaction is the very high reactivity. That is, substitution takes place at all the three positions. You cannot get it stopped. But if you want to control the reaction, what happens? You have an intermediate which is formed, that is aniline. When treated with acid anhydride and pyridine, you get an intermediate NHCOCH3, which on treatment with bromine and acetic acid, here again bromine only at the major position gets added, which again on hydrolysis the whole part gets removed and it becomes NH2. So this is just to avoid all the three positions of aniline getting occupied, but rather getting only one position of bromine. Next is nitration. Again same thing, we know which is the nitrating mixture, nitric acid and sulfuric acid, where you get again ortho para products. So which again to make only one position occupied, we treat it with acetic anhydride and pyridine, NHCOCH3 followed by nitration, NO2 comes, once on hydrolysis becomes NH2. So the concept, the reaction gets repeated the same time, you just need to understand what is getting removed. Once you come here, we will be definitely discussing the same. So sulfonation again children, with sulfuric acid, NH3HSO4, again you get SO3H, where this comes and occupies. There is an interchange within the molecule, forms as a Zwitter ion. What is a Zwitter ion? Zwitter ion is a compound where you have both cation and anion which is attached to the same compound, that you call it as a Zwitter ion. So with that the reactions of aniline gets over. Now you have a new compound set which is called as diazonium salt, which has the general formula Rn2 plus X minus. This R can be an aryl or an alkyl group. Mainly this will be only for aryl compounds, that is why we call it as diazonium salt. That is, X can be any chloride, bromide, or it can be sulfate, or it can be BF4 minus, any anion. Now what is basically happening here? Benzene diazonium chloride is prepared by the reaction of aniline with sodium nitrate and HCl. You remember we studied Sandmeyer's reaction in the first haloalkanes and haloarenes. Same thing happens here, aniline with sodium nitrite and HCl, you get benzene diazonium salt plus sodium chloride. So this is my benzene diazonium salt which is prepared. That reaction is called as diazotization. That is, our diazonium group, when it is treated with Ar represents my benzene. So we will see in replacement of halide and cyanide ion, Rn2 plus X minus, that is, it is a benzene diazonium salt. If I want my chlorobenzene, I use Cu2Cl2 plus HCl. If I want my bromobenzene, I use Cu2Br2 and HBr. Cyanobenzene, I use copper cyanide and potassium cyanide. So alternatively, I can decide which one I want. And if I want again chlorobenzene, I get different product. Here it is Cu2Cl2, here it is Cu and HCl. So using different reagent, the diazonium salt can be converted to my halobenzene. Okay, that is aryl benzene, aryl arenes, okay, haloarenes. Replacement of iodide can be done only with potassium iodide. This we discussed in Sandmeyer reaction. And if I want my fluoride ion, I should use HBF4 minus, because F2 directly will not get attached because they decompose immediately when it is formed. Now if I replace it with hydrogen, what happens actually when I use H3PO2 and water, I get my benzene ARH, that is in benzene C6H5, this hydrogen gets added, I get my benzene. With alcohol also I get my benzene. So if I want my benzene, I can use diazonium salt with H3PO2 and alcohol. Now if I am going to replace with water, I get my alcohol group, and if I want my nitro group, I can also do the same thing, where first I treat with HBF4 minus, which again on treatment with sodium nitrite and copper, I get my nitrobenzene. These reactions you may find it little bit confusing, children, but definitely when it comes with replacement, the structure is the same, only the reagents you should remember which one we are using. Next one is quite important, which we call it as a coupling reaction. In coupling reaction, azo products are obtained with N double bond N as a structure in the middle. Benzene diazonium chloride reacts with phenol, in which the phenol molecule at its para position is coupled with the diazonium salt to form para-hydroxyazobenzene. Now listen in this reaction very carefully what happens here. This is my diazonium salt which reacts with phenol. This comes out, HCl actually comes out, this N joins with this benzene, and this triple bond actually breaks into a double bond. So I get my para-hydroxybenzene, this is my orange dye. Here when it treated with aniline, I get my yellow dye. Again here HCl comes out, and the same para position of this joins with the nitrogen. Now these two reactions you will be actually doing in the lab, where you get a dye formed to confirm the presence of the organic compound amine. Importance of diazonium salts in aromatic compounds, very important, because the replacement of diazo groups has helped in preparing lot of aromatic compounds by the substitutions in benzene and its other reactions. So with this, amines is a very small chapter where you have lot of reactions, and I have decided that though they say the question papers it's going to be full of choice, definitely for those who are aiming for about 90-95, you need to study the entire chapter. So definitely children, when you come here, we'll be getting a lot of time to speak to you personally and also clarify the doubts that you all have personally. Bring your textbook when you are coming according to the timetable, so that I can even mark in the textbook when you come up with the doubts, and we can discuss more to learn more about each and every concept. Let us get the pattern so that you can do it. Do not miss any classes, come regularly because it's been a long time that you are at home. So when you come here, use the time wisely to understand better. Okay. Thank you children. Have a great day.